All right, so we're going to talk about density here, and you'll notice that I have a definition over here, and we're going to talk about this definition, which is very imprecise. And I actually did this intentionally because I think it's useful, a little bit more useful in this one in particular, to have a very imprecise, very loose definition of what density is, as compared to the mathematical traditional definition or physics definition of density, which is mass over volume. So this is mass over volume. That idea of density works really great when you're dealing with materials. All right, so another video I talked about this idea of how we're measuring different things. So the aluminum, the brass, the steel, and the copper pieces here. Which one has the greatest density? That's another way we can measure these, and which one has the most, right? The most what? The most density, the least density. And we talked about the idea that there being a really big giant disconnect between the aluminum one and the brass or the copper one. And the between the three of these, you're talking about the two heaviest ones versus definitely the lightest one. The steel is kind of in between those. But when we talk about density, we're referring to how much stuff is in a space. And that is a purposely imprecise definition. I think it's a very useful imprecise definition. So one of the things I did is I went back to this idea of having a defined space of some sort. And this could be a three-dimensional space, but in this case I'm actually using just a two-dimensional space for the demonstration purposes here. And I'm saying, well, how much stuff can I put in this space? In this particular instance, I'm using something that a lot of us can deal with fairly readily, and I'm just kind of putting dice on this side, and you can kind of see that they line up right on the edge on that side, and then the same thing along the top. And it's a little bit easier to see that right there. It actually sticks out to the side just a little bit, and it sticks out the bottom a little bit. So if we were to measure these, we go 1, 2, 3, 4, 5 this way, and 1, 2, 3, 4, 5, 6, 7, 8 that way. We're talking about almost 40 dice per 15 square inches. Okay, and that's a very it's an approximation. And then when we change that a great deal, when we change what we're talking about, so here's just another size dice here, same idea. And in this instance, you can see that those are not the same size. We'll talk about the height of the individual dice as well here in a second, but in this case, you've got 1, 2, 3, 4, 5, 6, 7, not quite 7, 7 and a half, 7 and a third, and going downward, 1, 2, 3, 4, that direction, almost 4. So it's 4 times, we can say 6 and a half or so. So that would be, about 28, 26 maybe. So, or we're talking about roughly 26 dice per 15 square inches. And that's the idea behind the density. And we can measure lots of different densities. And it all goes back to this idea of stuff over space. How else can we measure these things? How else can what other types of pieces can we deal with? What else can we put inside of here? Well, let's say that, and of course, there aren't any cities that are exactly rectangles or squares, right? But let's just say that we have a city here, and these represents the boundary lines. What if we have people? What if each dot represents a household even? Like, how many households do we have inside that space? We go through and count those and determine how many households, and that in itself would be density. So in this case, we wouldn't necessarily be talking about, say dice or inches. Maybe we're talking about 40 households per 15 square miles. And again, we're talking about a density. If we're talking about moving this into the 3 dimensions, well, there's our good old triangular prism, right? How many dice can we fit inside of that prism? Again, we're talking about a density. What is the count per stuff in there? So when we deal with densities, we're really talking about the idea of mass per volume. How much does something weigh versus what is the volume of the object itself? Like in this case, these two items here are the same exact size. And I can show you that by lining them up that way and lining them up that way, right? Okay, and then they're obviously the same diameter and length and all that stuff. But when you pick one up versus the other, you find that this one is heavier, which means there's more stuff inside the same amount of space which is talking about density. So which one would be more dense? If we were talking, we're still talking about this, say 26 households or 40 households. Well, it's, if we're still taking up the whole space, we're still taking up everything in there, whether we were talking about that dice or this dice. It just so happens that this one is bigger than this one. So of course we're going to be able to fit fewer into the same amount of space than we can with the smaller dice. So the idea being is that this is going to change our density, meaning we can fit fewer of these in than of these. If we make them even smaller, if we make even smaller quantities, let's say we're talking about them being like that big, well, we can fit even more of them in there. And we're still talking though about a density, which is stuff inside a space. And that space can be three-dimensionals, or it can be two-dimensionals as I have drawn here. And we can even talk in terms of people per city, people per car, people per bus, which is something we use a lot. And so a lot of different applications to this conversation around density. And it's not just a physics question. There are other social questions as well that we can answer that go along with this. So that is the basic form of how you measure density. And I want you to think about all the different types of densities that you can measure. Spend some time in just looking around, seeing what other densities can we identify. There are densities everywhere. If you just stop and you look at them, even going to the grocery store and how many apples are in the bag. That is a density question in some form. You are talking about so much per so much. So anyway, let me know if there's any questions you have, additional videos or explanations you need about this, and please keep doing some math. Take care.